Hello, and welcome back to Political Science 4781, Techniques of Political Analysis. In previous lectures, we've talked about visualizations involving time, and we've talked about visualizations involving space. So now, what I want to do today is talk about space-time, that is, visualizations involving both space and time, or visualizations in which the data are differentiated both across space and across time. There are a few different techniques that you can use for analyzing what are called in political science time series cross-sectional data. We can look at line graphs and spark lines from the lattice package, and that's what we'll do in this video. In the next video, we'll talk about stream graphs, map tiles, and Google Viz plots. So, as far as setup is concerned, what I want to do is pull down the same data that Professor Rosling used in his Health and Wealth of Nations video, just because we're already somewhat familiar with it, and this will give us a bit of a different perspective and show us different ways to look at the same data. So we'll call in the WDI library, which, as you remember, connects R to the API for the World Bank that gives us access to World Development Indicators data. And what we'll do is we're going to pull down indicators for GDP per capita, life expectancy, population, and a couple other indicators from 1960 to 2010 for all countries in the world. And when you summarize that, you'll see that you're getting a fair bit extra. One of the things that you're getting is data on aggregates, so the world or the Middle East or something along those lines. So what this middle line here does is it gets rid of any observation in which my data $ region is equal to aggregates. And once you've done that, you've got a data set consisting entirely of actual countries from 1960 to 2010. Then we'll use the names command to assign column names or variable names to each of the variables so that we can remember what they are, since the default variable names are not all that memorable. Then we're going to do a couple things down at the bottom here. We're going to create a lagged per capita GDP variable. That is, for 1962, I want to know what the GDP was last year. So the lag of GDP or GDP in 1961. And obviously the lag of per capita GDP in the first year, 1960, is going to be missing because we didn't pull down data for 1959. So what we do then at the bottom is we use current GDP and the lag of GDP to create a variable that reflects change in GDP, or percent change in GDP from one year to the next. And in order to do that, we just subtract the lag of per capita GDP from this year's GDP and divide it by this year's GDP. Okay? Divide it by last year's GDP. So this gives us a sense, from last year to this year, how much in percentage terms did GDP, per capita GDP, change. Now that we've got our data set up, we can take a look at how to do line graphs that are going to give us both temporal and spatial variation. So the first thing to do is to call in the lattice library. And the lattice library gives us a new command, xyplot. So what we're going to, and the interesting thing about xyplot is it allows us to group our data by some third variable. So we're going to graph life expectancy by year, and the little tilde there just means by. Don't. You'll see that every once in a while in some commands, and it's there in this one. So we're going to graph life expectancy on the y-axis and year on the x-axis. So it's you should note it's slightly different from the standard plot command, which is x, y. But then we're going to tell it to group the data by country. So don't just throw all the data up onto the screen. Draw a life expectancy by year graph for every single country. Type is going to equal L, so it's a line graph, and then we have the X label and the Y label. And when we do this, we get this fascinating Technicolor spaghetti thing going on here, which shows us, for most of the countries at most times, life expectancy going up. You see a couple of obvious deviations here to where there are abrupt dips in life expectancy. But for the most part, most of these lines are gradually climbing from the left to the right on the graph. So that's one way to represent these data. You might wonder how we can single out one particular country in the middle of all of this mess, right? If you wanted to look at not just at global trends, but at trends within a particular country, how would you go about doing that? Well, it's actually pretty straightforward. So what we're going to do is we're going to create a list of countries. Now, the My Data dataset has lots and lots of entries for every country. Right? So if we want to make a list of countries, we have to use the aggregate command, which is going to this is a bit of a hack here because there's no command that does it in a really clean way. We're going to aggregate life expectancy by country, okay? And we're going to create the sum of life expectancy for each country. So what we're going to do, we're adding up life expectancies from 1960 to 2010. That makes no sense, right? There's no reason you'd want to do that. That number is meaningless. But what you do at the very end, the left bracket, comma, 1 right bracket, is you tell it, well, I only want the first column, right? So when you create this life expectancy by country data set, the only column you want is the first country. The only column you want is the first column, which is the name of the countries. So in this clever way, we create data on life expectancy that we don't really care about, and then we throw it out. All we do is clip off the country names. Now, now that you have this list of countries, we are going to create a MyColor vector. And we're going to make all the colors for every one of the countries gray 85, which is a fairly light shade of gray. But on the third line here, we're going to turn the color in the color vector that's associated with the United States, we're going to make that color red. Okay, so all of these lines for all these countries are going to be gray, but the U.S. is going to be red. We're going to do the same with line width, which we haven't done before. Line LWD is the parameter used in the plot command for line width. So we're going to create a new variable, a new object in memory called myLWD, and it's going to be 1 for every country in the world. But then we're going to, on the next line, we go and find the United States, and we change myLWD for the United States to 2. Okay. Now that we've got this, we're going to do the same plot. Life expectancy distributed by year, grouped by country. Type is line, XLab, YLab, so on and so forth. Except we're going to add color equals mycol, line width equals myLWD, and the main title is United States. And when you do that, you get this sort of gray mess of spaghetti, but you get the United States standing out as a red line toward the top of the graph. So what happens if we want to do this with a different country? Let's say Rwanda. Same drill. You create the MyColor, or in this case, recreate the MyColor vector as a list of gray 85. You tell it, all right, go to the color entry in the color vector that's associated with Rwanda and turn that one red, and turn the line width from 1 to 2. And then we go through and we plot the same data, except now the color in MyColor vector is red for Rwanda rather than the U.S., and the width is 2 for Rwanda rather than the U.S. And we can see when we do that Rwanda is one of the countries that dips down most abruptly during the period of the genocides between the Tutsis and Hutu. Okay, so that's one way to display data in a time series cross-sectional fashion. Another is what's called spark lines, and we've talked briefly about these in a previous lecture. They're actually not terribly difficult to do. Instead of grouping data by a third variable, you use this vertical bar, and that's usually on most keyboards it's right above the / key. And so you put life expectancy on the y-axis, year on the x-axis, then you use this vertical bar, and the next variable you put in is the variable that differentiates one plot from another. So we're going to use ISO 3C, which is the country code. We're not going to use the country name for a reason you'll see in just a moment, but we'll get to that in a second. Type is L, so it's a line graph. X label is year, Y label is life expectancy, and we're going to scale the size of the plot and the text down a little bit using the CEX subcommands and a couple of XY plot subcommands, scales and parstrip text. And we're going to make the background white. Okay, when you do all of this, what you see, you get the data grouped by ISO 3C code. And the reason here that we chose ISO 3C codes is that the full name of most of these countries would not fit in this little pink area above the graph. But the three-letter codes do. So when we create this graph, you can see it's a little bit, you might want to sort of reverse the order of the countries so that it goes goes in alphabetical order from top to bottom. But you can take a look at these little lines that give you trends for different countries, and that allows you pretty quickly to see. You can look over on the left, you can see the Iran-Iraq war had an impact on life expectancy in both Iran and Iraq. And you can see other dips and surges in life expectancy for other countries. So these are a couple of the neat commands that you get from the Lattice package that allow you to look at data both across time and across space.